This is the most exciting development we've seen all year. The scatter plot clearly shows the new cluster consolidating.
What if machines could uncover secrets hidden in mountains of data without ever being told what to look for? Welcome to the world of unsupervised learning, where algorithms explore unlabeled data to reveal patterns we never knew existed.
Imagine you're a telecom engineer tasked with improving network coverage. You have millions of call location points, but no labels. By applying a clustering algorithm, you can group the data and find the optimal locations for new cell towers. The model reveals where people are naturally clustered, guiding your investment and improving signal for everyone. That's unsupervised learning, turning raw data into actionable insight.
Unsupervised learning is a type of machine learning that draws inferences from unlabeled data. Instead of learning from examples with known answers, the algorithm explores the data's structure, discovering hidden patterns, relationships, and groupings. It's particularly useful when labeling data is expensive or impossible. Before training a classifier, unsupervised learning can also help identify meaningful features during exploratory analysis.
Unlike supervised learning, which uses labeled data to predict outcomes, unsupervised learning simply wants to understand the data, what makes points similar or different. It's like giving a toddler a box of mixed blocks and watching them sort by shape or color without instructions.
The process starts with data preparation, cleaning and normalizing raw inputs. Next, you choose an algorithm suited to your goal. Clustering is used to group similar data points, while dimensionality reduction simplifies high-dimensional data. Finally, you interpret the results, visualizing clusters or inspecting principal components. Unsupervised learning often precedes supervised learning by identifying patterns or reducing dimensionality as part of feature engineering.
Clustering is the most common unsupervised method. It seeks natural groupings in your data so that points within a cluster are more similar to each other than to those in other clusters. There are two main categories: hard clustering, where each data point belongs to exactly one cluster, like in k-means, and soft clustering, where points can belong to multiple clusters with varying degrees, like in Gaussian mixture models.
Popular clustering algorithms include hierarchical clustering, which builds a tree of clusters, k-means, which partitions data around centroids, DBSCAN, which finds clusters based on density and detects outliers, self-organizing maps, a type of neural network that learns the data topology, and spectral clustering, which converts data into a graph and separates clusters using eigenvalues.
High-dimensional data, like wearable sensors capturing dozens of variables, can be hard to visualize and compute with. Dimensionality reduction techniques condense these variables into a smaller set that retains the original information.
Methods like principal component analysis, PCA, transform data into orthogonal components that capture maximum variance. SNE excels at visualizing clusters in 2 or 3 dimensions. Factor analysis uncovers latent factors influencing multiple variables. And autoencoders, neural networks trained to reconstruct their input, learn a compressed, latent representation useful for anomaly detection and image generation. Another branch of unsupervised learning is association rule mining, which discovers relationships between variables in large databases. In retail, association rules uncover which products are frequently purchased together, market basket analysis. These rules also support predictive maintenance. By analyzing sensor data, algorithms can learn combinations of signals that precede a machine failure.
Unsupervised learning underpins many applications. Exploratory data analysis uses clustering to reveal structures and trends. In anomaly detection, algorithms like isolation forests or Gaussian mixtures spot unusual patterns. Medical imaging uses clustering to segment organs and detect tumors. Genomics relies on clustering to group gene expression profiles. Streaming platforms employ recommendation systems based on unsupervised techniques like singular value decomposition. In natural language processing, topic modeling and document clustering find hidden themes in text.
Because no labels are needed, unsupervised learning is invaluable when labeling is impractical or expensive. However, results can be less precise than supervised methods because there's no ground truth for the model to emulate. Still, by revealing hidden structures, unsupervised learning provides insight that can drive discovery and innovation.
Unsupervised learning lets machines explore data without a map, grouping, simplifying, and uncovering associations that we might never see ourselves. Try clustering your own data or visualizing high-dimensional information with PCA. If you found this episode enlightening, like, share, and subscribe. Drop a comment with your favorite unsupervised learning application, and stay tuned as we dive deeper into the world of machine learning.
Find our digital. These visualizations aren't just abstract art. They are the keys to understanding the clusters that define our digital ecosystem.
So here you can see the algorithm in action. As I tap here, the data points start to cluster together. So here